we'll call it a relative or local maximum. So if we're going to define a local or relative minimum, a function f of x has a local relative minimum at x equals b if there is an open interval y in which f of b is less than or equal to f of x for x in all x and I. All right, so that makes sense. Just a little bit of defining. Now, there's some who struck about these things, and the first thing that we need to know, both the absolute and local maximums and minimums come together in what's called the extreme value theorem. So, like I said, it's going to be a lot of blab. The extreme value theorem, which will also seem intuitively true. All right, if f is a continuous function, 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 I'm going to continue to say it until it sticks in your mind that when we're looking at this extreme value theorem, it only applies to continuous functions. So no functions with holes, skips, or asymptotes. So if f is a continuous function on the closed interval, a to b, that's including the endpoints, then f, that's the name of the function, if f, then f obtains or attains both an absolute max and an absolute min. On AB. All right. Did that whole thing fit in here? Here. There we go. And that's the extreme value theorem, and it makes sense. All right. All right, from there, we're going to go ahead and look at a place where we go. It's like guidelines for looking for extrema when you have a closed interval. And I think that's about all we're going to do for tonight. And we'll use those guidelines in class tomorrow. So, where are we going to look to find extrema on a closed interval? So there are 4 places we could look. And again, we're on a closed interval, so it's going to be A on one side, B on the other, and then everything in between. So we can find that we can look at critical numbers. Some more about that in a second. We can find the extrema So to look for the extrema, we're going to find the critical numbers. So the critical numbers are places where the function is either zero, I'm sorry, not the function, the derivative is either 0 or the derivative doesn't exist. That's the critical numbers. So, for example, if we had a function which had a zero derivative right there, that's a critical number. But what if we had a sharp turn, like right here? That's no derivative. So that's also a critical number. So we're going to look for our extrema at critical numbers. We're going to look for our extrema at endpoints. So we're going to look right at A and right at B. And lastly, we are going to look at evaluate the function at each critical number. Find the critical numbers, just a minute here. Find the critical numbers, evaluate the function. Okay, so we're going to look at the critical numbers and we're going to look at the endpoints. That's where we're going to look. And then what we're going to conclude is we're going to look at the value for y, the f of x value, at all of these critical numbers and at all of these endpoints. The greatest one is going to be called the maximum, and the least is going to be called the minimum. So that's where we're going to look in these two spots. So there are 4 steps. I mentioned 4 before, but there's only really 2 spots that we're going to look, and that's where we're going to find our critical numbers. And I said that was the last thing. Hopefully I have time to make one more point, and that is if the function, if f has a relative max or min at x equals c, then c is a critical number. What's critical number again? Then critical numbers are where the function either has a derivative that's 0 or it does not exist. So, and remember, this is still continuous. So we're not talking about it doesn't exist because there's a whole jump or a skip or an asymptote. We're talking about it doesn't exist because there's a very sharp turn. So those are the 2 places we can look, and at the endpoints. And again, we'll conclude if the function has a relative max or min at x equals c, then c is a critical number. So that's why we're taking these spots and looking for them. All right, we'll put that together tomorrow with some problems. So for now, you mull on that, digest it, chew on it, dream about it, and I'll see you tomorrow.